Hello and welcome. We're going to do a very quick dive into MCP. You might have heard this acronym before. It starts to come up in the world of AI and agentic systems, and I want to deconstruct what it actually means and why it's important. So let's start with the foundation here, which is interacting with GPTs, AIs, LLMs. We're all probably used to this by now, this conversational interface where you can ask questions and gather information using a UI and essentially talking or having a conversation with a language model. So things like ChatGPT, Claude, Gemini. You can use these language models to get answers, to refine documents, to help you create content, tons of applications. Now, these LLMs are trained on tons of information. They're models. And this is a one-time exercise, this training job. And it takes tons of computational resources because it uses tons of data. Think of kind of all of the information that we have access to on the internet, documents, data, Wikipedia, news sources, books, research papers, all of that information gets funneled into these language models so that they have tons of context and awareness. And that allows them to answer questions for you. Things like, what is the capital of Tasmania? It's Hobart. I wouldn't have known that without an LLM, at least when I Googled it just before this. Thank you, Gemini. So again, this happens one time, this training job. So whenever you're asking a question of a language model, you're typically getting information up until the point at which it was trained. But what if I want more recent information? Let's say I want to know what was the temperature in Portland, Oregon yesterday. Now, if I'm asking an LLM and it was trained several months ago, it won't have that information. Although it might guess, it still won't have the actual information because that happened more recently than when it was trained. So how do we solve this problem? Well, one of the easiest ways is to give the LLM access to the internet, and then it can look up what the weather was in Portland, Oregon yesterday and tell me that it was 78 degrees and likely a little bit rainy. So that's fantastic. That means that we have all of this information as well as more additional recent information that we can get via our language models and our AIs. Let's go a little bit deeper. Let's say I want help summarizing all of my emails from yesterday. So now we need to give the LLM even more context and information. In this case, we would need to give it access to my emails. So access to my local email server. And now let's say we want to go even further. And I want to ask, what were my sales last quarter? And now I happen to know that my sales information is stored in my Exasol database. So what if I want to be able to ask this question? How do I give that additional information context to the LLM? And this is where MCP comes into play because we've created a way to give LLMs additional context from tools and platforms beyond the original training data, things like the internet, things like web servers, and things like your actual analytics database. Now, of course, providing that context and information requires guardrails so that we can be very clear about what data can be accessed, what actions can be performed, and how that data should be provided to both the LLM and the user. So we define these set of interactions that the LLM can make with these various tools and platforms via something called the Model Context Protocol. So these interactions between the language models and various tools and platforms like Exasol are all defined and organized via this Model Context Protocol. So it's a standardized way for AI systems, particularly large language models, to interact with external tools and data sources. Now, once we combine all of this information and capability, we open up a ton of new possibilities for this conversational interface because we give it so much more additional information. Now let's take a look at how this works in real time. All right, so today we're going to use Claude Desktop to explore the data that we have in our Exasol database. Now, to give Claude access to Exasol, we're going to be using one of these integrations. And you can see here, Exasol DB is actually the MCP server that we've built and includes a variety of different tools, such as list tables, list schemas, execute query, that allow Claude to interact with that data within our database. In the backend, we've also specified the Exasol database connection string as well as the credentials that it will need to get access. So let's start with a pretty basic question. Tell me the tables in my Exasol database. Now, as Claude goes through and tries to answer this question, it's going to start using a variety of the different tools available in the MCP server. So the first one is the list schema tools. And anytime we see it using a tool, we can see both the request and the response. So we can understand sort of what's happening behind the scenes. Listing the schemas and listing the tables provides all of the information needed to answer my question. And here's an overview of the tables in my Exasol database. And this is pdemo that I'm using here. So we've got retail, flights, taxi data, banking data, and many other interesting databases as well. So you can see that there's the underlying raw data, the metadata, the schemas, the tables, and then Claude has actually organized this logically to kind of give me that overview that I'm looking for. So now that we know what data is available, let's ask some more specific questions. Let's work with the flights data set. So give me a sample of the flights data. And now we can see that Cloud is going to start using some additional tools. So now it's going to use describe table and execute query. So it's going to pull out a sample of that flights data set for me. And it's going to go even deeper here and also pull some summary statistics to really provide a comprehensive answer. Fantastic. So first we get that sample data. You can see that's organized in a tabular format here. One thing I'd like to point out is that I'm actually not writing any SQL here. Claude is pulling all of this together using its own awareness, its own knowledge, combined with the tools available in the Exasol MCP server. Fantastic. Now we get some pretty comprehensive overview information, and Claude has even pulled out some key data points that are available. So let's say now I want to ask a more specific question. What is the longest flight? Now we're actually going to start to go in and do some slightly more analytical exploration, asking more specific questions about our data. And let's see how Claude interprets that and what sort of query it asks or it issues to be able to answer that question. So it's ordering by distance, and it's checking both distance and also flight time as well. And here we have our answer. The longest flight is this Hawaiian Airlines flight from Boston to Hawaii. I'd even looked at some other notable long routes as well. It even calls out this interesting anomaly where there's a 25-hour airtime flight, which is probably a data issue or there's something else going on here. So you can see just by asking one simple question, I get a very comprehensive answer. I also get all of the queries that were used to get this data. So if I want to go in and check that myself, I can. So that's just a quick sneak peek at what Cloud can do. And then there's so much more. So by combining the power of LLMs with the MCP server that gives the LLM additional context and access to our Exasol database, we can do really deep analytics. You can imagine how deep we could go with this. But we also have simplified and streamlined access to this data. Since I don't necessarily need to be in there writing all of these SQL queries, I can have essentially a conversation with my data. And that is pretty darn cool.